Problem 4. Two insulated rings, one of slightly smaller diameter than the other, are suspended along their common diameter. Initially, the planes of the rings are mutually perpendicular. When a steady current is set up in them, four options are given. A. The two rings rotate into common plane. The inner ring oscillates about mean position. C. Outer ring remains stationary and inner ring moves into the plane of the outer ring. D. Inner ring remains stationary and the outer ring moves into the plane of the inner ring. So, we have to examine the torque on the rings. We have to examine the torque on the ring, assuming ring 2 is situated in the magnetic field of ring 1 and ring 1 is situated in the magnetic field of the ring 2. Okay. From this knowledge of the torque, we can predict whether the rings will rotate into a common plane, etc. Okay. First, let us draw the diagram for this case. So, this is ring 1 having a diameter R1 carrying current I1. This is ring 2 having radius R2, radius R1, current I1, radius R2, current I2. This is the xy plane and this is yz plane. So, ring 1 is in the xy plane and ring 2 is in the yz plane. Let us calculate first B1 and B2. B1 equal to mu naught I1 by 2 R1, and always the magnetic field is perpendicular to the plane. So, what is unit vector perpendicular to xy plane? K vector. Similarly, B2 will be mu naught I2 by 2 R2, yz plane I vector. Tau 1 equal to the torque due to the first on the second ring. So, it is the magnetic moment of the two rings. Let us calculate M1 and M2. M1 is the magnetic moment due to the first ring, which is I1 A1, which can be written as I1 A1, then K vector, because area vector perpendicular to the plane. Similarly, M2 will be equal to I2 A2 vector or I2 A2 I vector. Tau 1 equal to M1 cross B2. Let us calculate this. Tau 1 equal to I1 A1 K cross mu naught I2 by 2 R2 I. Let us not bother about the magnitude. We will see the direction K cross I. K cross I is J. Tau 2 equal to M2 cross B1. What is M2? I2 A2 I cross mu naught I1 by 2 R1 K. So, it becomes I cross K minus J. So, we see the direction of the torque on the first ring is J, that is positive y axis, and the direction of torque on the second ring is along the negative y direction minus J. Therefore, the two rings will rotate into a common plane and the option is A.